Hello, thank you so much for tuning in to my YouTube channel. In today's video, I want to talk about the impact of the color of the object on the performance of the convolutional neural network in object detection. In order to do that, I'm going to be training a CNN on images that contain white rectangles on a black background, and then I'm going to be testing the network on images that contain blue rectangles on a black background. So the colors of the objects in the testing and in the training samples are not the same. So we're gonna see what happens. Let's get started. As I said in this video, I want to talk about the impact of the color of the object on the performance of object detection using CNN. To do that, again, the same problem of object detection that we talked about in one of the prior videos is going to be used in this video as well. In that problem, we synthesized a simple rectangle in an image and tried to detect it. This simple problem could give us a lot of understanding on object detection and enables us to change a few factors such as the color of the object to be detected and see the resulting outcome. As a reminder, the problem consists of detecting a rectangle of random size and random location somewhere in the image. As you can see, these are some of the examples. The pixels inside the rectangle are set to 1. And outside the rectangle are set to 0. In other words, the color of the rectangles to be detected by the CNN herein is white because RGB are set to 1. In this video, I'm gonna be training the CNN on images with white rectangle as shown here. But then I'm gonna test the network on rectangles of blue colors to see if the network would be able to detect the object in the test set. In other words, the network is going to be trained on these types of rectangles, the white rectangles, and it's going to be tested on blue rectangles. The background will be set to 0, which is the black color. The images are created as a bunch of 8x8 NumPy arrays. This is the CNN that I'm going to be using for this problem, and we already talked about it before, but as a reminder, we can see that the network gets in the image and outputs the XY coordinates of the image along with its width and height. The width and height of the rectangle, of course, inside the image. This network has been already used in one of the prior videos, as I already talked about. And intersection over union computed between the predicted box and the real box is going to be used as a way to evaluate the performance of our network. So intersection over union. One of them is the predicted, the other one is the real box. Okay, let's go to Python and show you guys the code and also get some run. Okay, here's the code that I used for synthesizing blue rectangle. 50,000 images are going to be synthesized. This is where the rectangle is going to be put into the image along with the coordinates and height and width of them. And then the images are normalized, as I said before, with respect to their mean and standard deviation. And the images themselves, they're going to be normalized so that the values will be between 0 and 1. And I mean the box are going to be, the coordinates are also going to be normalized, so they will be between 0 and 1, and the test and train would be separated. This is only for train because the rectangles here are all black. I mean the rectangles are white and the background is black. Here I'm making the blue rectangle inside the image. How I do it is I would set the last channel to 1 and the other as 0. That would make the rectangle look blue. And again, normalizing the characteristic of the rectangle, including x and y coordinates and width and height, and that would be my test sample. So the rectangles in the training set is white, and the rectangles in the test set is blue. And this is the this is a convolutional neural network. It's not a deep convolutional neural network. It has one convolutional layer along with the dense layer, two dense layers. One of them, the last one, has 4 neurons, which would lead to 4 sets of data that we need: coordinates, XY coordinates, and also width and height of the rectangle. And it's going to be trained, and the prediction is going to be done, and we see if the network that is trained on the white rectangles would be able to detect the blue rectangles in the image. This is going to be going for 450 epochs. Let's run and see what happens. As you can see, this is the blue rectangle. The mean intersection over union over all the images is 0.12. Let's write that down so that we know what we did here. 0.12. Let's say 0.13, so I would be rounding it up. 0.13, and you can see that it hasn't done well. In one case it's 0, and in other case it's 0.25, and this is only 2 randomly chosen samples, but overall it's 0.13. We already talked about the network, and yeah, let's go and run the other one that has both rectangles that are white in both training and testing samples. Let's see what happens there. So this is the other network. It only has one set of colors for rectangles. They're all white. So the test and train has rectangles that are white, and I've already talked about this network in one of the prior videos. You could also look at it very quickly. This is where rectangles are made, and then the normalization of the images, and then the normalization of the characteristics of the rectangles inside the image. And the network is same as before. The number of epochs, everything is the same. And yeah, let's see the result of object detection when both rectangles in training and testing have the same color. And this is the result. As you can see, is 0.8 and 0.98, and on average the performance in terms of intersection over union is 0.89, which is way higher than 0.13 that we obtained when we use different colors in training and testing sets. So you could see that the average IOU, intersection over union, here is 0.89, which is way higher than 0.13 that we obtained when we use different colors of rectangle in training and testing sets. But when the colors are the same in training and testing set, the performance of CNN in object detection is very high, which makes sense. So one of the most important factors in object detection we find out here is the color of object, and we have to make sure that the color of objects in training and testing samples are the same. And in other words, the training sample should be very general, and it should have all the colors possible in our testing. Otherwise, the result of the object detection is not going to be that good. Thank you so much for watching this video. It was an interesting video to show that the color of the objects is of great importance, and we have to always bear in mind that in order to be able to detect all the objects in our testing samples, colors of the object in our training and testing samples is of great importance as well. And we have to cover all the colors in our testing samples in our training samples in order for us to be able to detect all the objects in our testing samples. If you like the video, I would appreciate if you subscribe to my channel and also like this video, or also share it with your friends. Thank you so much. Have a nice day.